Differentiation is the rate of change of f of x with respect to x. The derived function is denoted by f dash of x. It can also be written as dy by dx, which is the change in y over the change in x when y equals f of x. Differentiation allows you to find the gradient of any point on the curve. It also allows you to find the gradient of the turning points on a curve and determine its nature, whether it's a maximum or a minimum. Here is a graph to show what I mean. So the curve increases to a maximum point and decreases to a minimum point. These 2 points are all the turning points on a curve. How to differentiate? So here we have f of x equals ax to the power of n. When you differentiate it, you get f dash of x equals nax to the power of n minus 1. So here, this is the power, and this is the coefficient of x. So to differentiate, you multiply the coefficient of x by the power of x. When you do that, you have to decrease the power of x by 1. So here, n times a equals na. So the power of x multiplied by the coefficient of x gives you na. And as you do that, you have to decrease the power of x by 1, so n minus 1. So that gives you f dash of x equals nax to the power of n minus 1. So here's an example to show what I mean. F of x equals 6x squared. Y equals 6x squared because y equals f of x. So what's happening here is to differentiate this, you have to do 2 times 6, which gives you 12, and then you decrease the power of x by 1. So you minus 1 from 2 to give you 1, so it will be 12x to the power of 1, but you don't need to write the 1, so you just put 12x. Okay, so double differentiation allows you to determine whether the turning point on a curve is a minimum or a maximum. Okay, so here we have an equation, y equals 4x cubed plus 9x squared. So to differentiate that, we do dy by dx. So 3 times 4, so the power of x multiplied by the coefficient of x is 3 times 4, which gives you 12. And as you do that, you have to decrease the power of x by 1, so you get 12x squared. And then you have to do the same thing here. So 2 times 9 gives you 18. And then you decrease this power to 1, so you get 18x. With double differentiation, you have to differentiate this equation twice. So we've done it once here, now we're going to do it again here. So d2y by dx squared equals 2 times 12, which is 24, decrease the power of x by 1 to give you 24x. And then do the same thing here. So here, this is actually 18x to the power of 1, but we don't write the 1 here. So 1 times 18 gives you 18, and then you decrease the power of x, which is 1, to 0. So 1 minus 1 gives you 0, but anything to the power of 0 equals 1. So x to the power of 0 equals 1. So you just times 1 and 18 to give you 18. So here is an example of a turning point on the curve. We want to determine whether it's a minimum point or a maximum point. So here are the coordinates for the turning point. So you use the x value, which is 8, and you input that into this equation here. So anywhere you see an x, like here, you put this value into it. So 24 times 8 plus 18. If the answer is greater than 0, it's going to be a minimum point, and if the answer is less than 0, it's going to be a maximum point. I'm now going to do an exam question from a past paper, OCR MEI January 2012 C2. I'm going to do question 12 of the past paper. So here the question asks me to show that the curve meets the x-axis at the origin and at x equals plus or minus a, stating the value of a. So here, I'm just going to write the equation again. So y equals 9x squared minus x to the power of 4. but here you have to make it equal to 0 to find out where the curve meets the x-axis at the origin. So what's common between these two is x squared. So you take x squared out of the equation, so you get 9 minus x squared equals 0. So you do these two parts separately. So x squared equals 0. And to get x on its own, you have to square root 0 to have just x. So x equals square root of 0, which equals 0. So here, x equals 0. So I've just proven that the curve meets the x-axis at the origin because the coordinates of the origin are 0, 0, and here x equals 0, and the x value of these coordinates is also 0, showing that the curve meets the x-axis at that point at the origin. Okay, so now we have to do this part of the equation, which is 9 minus x squared equals 0. So you have to get x on its own. I'm going to take the 9 onto the other side, so minus x squared equals minus 9, and the minuses cancel, so you just get x squared minus 9 equals 9, and then to get rid of the squared here, you have to square root 9, and this gives you plus 3 and minus 3, because 3 squared equals 9 and minus 3 squared also equals 9, so you have to put plus 3 and minus 3, and as I said in the equation, in the question, and at x equals plus or minus a, stating the value of a. So here, the answer to the question is a equals plus or minus 3. In the second part of the question, it asks me to find dy by dx and d2y by dx squared. And then it says, hence show the origin is a minimum point on the curve and find the x coordinates of the maximum points. So first of all, I'm going to find dy by dx. So the equation was y equals 9x squared minus x to the power of 4. When I differentiate that, I do 2 times 9, which is 18, and then decrease the power of x by 1 to give me x on its own. And then here I have to differentiate this part of the equation, which is 4 times 1, because x on its own is 1x to the power of 4, but we don't write the 1, so 4 times 1 is 4. And then decrease the power of x by 1 to give me x to the power of 3. So to double differentiate, it is this equation which I'll be differentiating again. This equation which I'll be differentiating. So it will be this has basically been differentiated twice. So this was the first step, and now this is the second step. So 18x minus 4x cubed, 18x to the power of 1, so 1 times 18 gives me 18, and then when I decrease the power of x, I get x to the power of 0, which is 1, so just 18. Then 3 times 4 gives me 12, and then the power of x decreases by 1, so I get 12x squared. Okay, the question says, show the origin is a minimum point on the curve. We know that the coordinates of the origin are 0, 0, so I input the x value into this equation. So I get 18 minus 12 times 0 squared, which equals 18. This is because 0 squared is 0, and anything times 0 is going to be 0. So 12 times 0 is 0, giving me 18. And as I said before, d2y by dx squared. When it is greater than 0, the turning point is going to be a minimum. So in this case, 18 is greater than 0, so therefore the turning point is a minimum. Okay, so the other part of the equation of the question is find the x coordinates of the maximum points. So we have to use this equation here to find the turning points of the curve. So dy by dx equals 18x minus 4x cubed. We have to make this equal to 0. So what you do here is you take out what's common between these two, which is 2x, and then you get 9 minus 2x squared equals 0. So you do this separately. 2x equals 0, therefore x also equals 0, because 0 divided by 2 just gives you 0. And then here you do the second part, which is the other part, which is 9 minus 2x squared, which equals 0. So you take the 9 onto the other side, giving you minus 2x minus 9 equals minus 9. The minuses cancel to give you just 2x squared equals 9. And then to get x on its own, you do x equals 9 divided by 2, which equals 4.5. And then to get x completely on its own, you take the squared, so the power of 2 onto the other side, so you square root 4.5 to give you plus or minus 4.5, and that is the answer, because it asks for maximum points. So therefore x equals 4.5 and minus 4.5.